Hello students. In the previous lecture, we were talking about control structure in Python under the subject programming in Python. We completed up to the if and if else and then followed by if elif else structure. Now we will be starting the iteration part. I'm moving to the next slide, which is actually the 12th slide in the same, and it actually says the concept of iteration control structure. So when we talk about iteration, what are actually an iteration? What is actually an iteration? An iteration is something that is going to be executed repeatedly. So every time we are executing anything, it is actually an iteration. So there are some instructions that need repeating a number of times. Right? For that, we actually term them as an iteration. So if a task is getting repeated 10 times, we say that the iteration has been done 10 times, or the task has been given 10 iterations. So in Python, iteration is achieved using two different kinds of loops. One is called the while loop and the other is called the for loop. So let's talk about the while loop first. So a while loop actually has three parts. The first thing is variable initialization. The second thing is condition check. And the third thing is either the increment or the decrement operation in order to make the condition false. Right? The statements in the loop gets executed repeatedly until the condition becomes false. So the loop is actually like that it will be checking the condition, and if the condition is true, it will be executing the statement or the block. Then it will be again checking the condition. Then it will be again going for the block execution if the condition is true, and it will be going again and again. It will be going again and again until the condition becomes false. And as soon as the condition becomes false, it will be moving out of the loop. So when a diagram is to be checked, you can see that we are moving from the top. This is a part of the program, and we are actually entering the while loop. So we have a text expression. So this is the text expression you can see. Then if this text expression is true, some statement will be getting executed, and again the text expression will be evaluated, and this will be actually forming a loop. So until this condition becomes false, it will be forming a loop. It will be again and again doing the same task. It is actually meaning it will be executing the same set of statements again and again after checking this particular condition. As soon as this condition becomes false, it will be moving out of the loop. So this is actually a diagram that actually identifies how the while loop works. So let us see the syntax of the while loop. The syntax of the while loop is actually, I told you that it contains three parts. So the first part is the initialization, the second part is the condition check, and the third part is the increment or the decrement operation that is to be done inside the block of the while loop. So we are going to have a variable. This variable can be named as anything. So variable equal to value is required. Then while sorry, we are going to start the while loop after giving a condition, and this condition must include this particular variable that you have initialized, and a colon is required. And I have told you that after the colon, the next line is going to be indented. So we are starting with a block of code which will be executed when the condition becomes true. So we have, let us suppose, three statements which we want to be get executed, and then at last we are actually putting the increment or decrement operation on the variable, so that this variable value must get changed in order to make the condition as false. Because until the condition become false, we are not going to come out of the loop. And this is statement 4, and you can see that its indentation is 0, so it means it is outside the loop. So this statement will definitely get executed when the loop gets over, right? So let us take an example. That this example says this, it is just the same as that, only that the above case. We are having a variable x, we have initialized the value as 0, and the condition that we are giving in the while loop is x less than 5. So until the value of x becomes 5, it will be executing again and again the two statements, which will be print I love programming and the value of x, which is to be increased by 1. So initially the value of x is 0. So because x less than 5 is true, so it will be moving inside the loop and it will be printing I love programming, right? So I love programming will be printed because the value of x is 0. So the condition is true. and it will be changing the value of x to 1, because the next statement says x equal to x plus 1. Then it will be again checking the loop, which checking the condition, which is 1 less than 5. 1 less than 5 is again true, so it is going to give I love programming again, and the value of x will be changed to 2. And then it will be again checking for the condition, which is 2 is less than 5 is true, so I love programming is printed, and the value of x is changed to 3. So it will again go for checking the condition of the loop. So 3 less than 5 is true. So it will again print I love programming, and x will be changed to 4. And then 4 less than 5 is true. So I love programming will be printed once again, and the value of x will be changed to 5, because x is 5 now. So now 5 less than 5 is false. So it will be a false condition. So it will not be moving inside the loop. It will be moving outside. So it will be printing Python is easy. So this is the output of this small code or small snippet which you can understand. Let us take a very good example of that. Let me let me want to write a program that asks the user to input a number and print its table. So the table of the number I want that it should be printed. So how I'm going to take, the first thing that I want is to ask the user to input a number that should be an integer value, and to store it in the variable. So how I'm going to do that? I hope you are well versed with this thing now. That this statement will be asking the user to input a number, and that number will be converted into integer and will be stored in the variable n. So now I've taken t. T will be actually identifying how many times I have to multiply, because for a table, when the table is for, let us suppose it's for 5. So 5 multiplied by 1 is 5, then 5 multiplied by 2 is 10, 5 multiplied by 3 is 15. So multiplied by what? Multiplied by times is actually being accessed by the value of t. So I will be changing the value of t from 1 to 2, 2 to 3, 3 to 4, and so on, up to it becomes 10. And as soon as it becomes 11, I will be moving out of the loop. So my loop actually has the condition that the value of t should be less than or equal to 10. I could have also taken the condition as t less than 11. It is same as that only. So in the indented manner, I'm just calculating the result. So n multiplied by t I'm getting, and then I'm printing the value as per the format. So n, the value of n will be printed, star will be printed, the value of t will be printed, equal to will be printed, and the value of result will be printed. So, and every time after doing this print statement, I'm going to increase the value of t by 1, so that the value of t can be increased. So initially it was 5 multiplied by 1. Now it is 5 multiplied by 2. Next time it will be 5 multiplied by 3, and so on. And this t value will be actually being checked again and again, that it should be less than or equal to 10. And as soon as it becomes 11, we will be moving out of the loop. So just for the sake of simplicity, I have written table of n printed, so that you may understand that after the loop gets over, the control moves out of the loop and it comes to the new line. So how the output would be? The output would be somewhat like this. It would be first asking enter a number whose table you want, and let us suppose you have entered 9. So it will be printing 9 multiplied by 1 equal to 9, 9 multiplied by 2 equal to 8, and 9 multiplied by 3 equal to 27, and so on. 9 multiplied by 10 equal to 90. And after the completion of the loop, it will be saying table of 9 printed. So I hope you can understand this concept. This is not very difficult to understand, that the loop statement, the block of statement gets executed again and again until the condition becomes false. And here, as soon as the value of t becomes 11, you are moved out of the loop, and table of 9 is printed on the screen. Just in the same manner, let us see what is the logic behind finding the reverse of a number. So let us see that how the reverse of a number can be found out. As soon as I ask you that what is the reverse of 1243, you would be telling me that the reverse is 3421. 3421 is the reverse of 1243. But when I ask you what logic you have applied, you said that just by looking at this number, I can identify that the reverse is this. But a computer does not have eyes. A computer cannot see a number. It is actually stored a number. So we need to have a logic that identifies the reverse of a number. So let us see how the reverse can be calculated by the computer. So we are going to have a variable rev, for example. The variable name can be anything. And I'm initializing the value as 0. and then I'm extracting the last digit from the value of n, and then I'm applying the formula reverse equal to reverse into 10 plus last digit. So this particular thing followed by I'm going to remove the last digit from the value of n. This particular thing, these three statements are going to be executed again and again until the number becomes zero, because every time you are removing the last digit, it is one digit less than the previous number. So there will be a time when the complete number becomes zero. So let us take will it work? So initially we are having the value of rev as 0 and the value of n as 1243. Then if we are applying the formula rev equal to 0 multiplied by 10 plus 3, 3 is actually the last digit. So the value of rev becomes 3, and the new value of n becomes 124 because we have removed the last digit. So we are applying the same thing. Then the value of REV becomes 34 because 3 into 10 plus 4. 3 is the initial value of REV. 10 we are having hard coded, and 4 is the last digit of 124. So by calculating, we can find out that REV becomes 34, and the new value of n becomes 12 because 4 has been removed from there. Then again the same thing, reverse equal to the value of REV, which is 34, multiplied by 10 plus last digit is 2. So we are getting the value of REV as 342, and the new value of n becomes 1. And lastly, when we do the same thing, we get the REV value as 3421, and the value becomes 0 for n. And this process was to be repeated until the value becomes 0. And now the n has become 0, so we will be ending here. Now REV contains exactly the reverse of the number which was entered by the user. So you can see that 3421 is now the value stored in the variable REV. So we can instruct the computer to find the reverse of a number by giving this particular algorithm. How we are going to do that? We are going to do in the same manner. Let us see that this statement, what it is going to do. It is going to first ask the user to input a number, and that will be stored in the integer format in the variable n. So I'm taking a copy of the number so that if my number becomes 0 at the end of the program, I can also have my original number. So I have taken another variable copy, and that will be storing the same value of n in the beginning. And now I will be making the value of copy as 0, but the value of n will remain intact. So initially I'm giving the initial value of REV, which is 0. Then a loop, I'm going to specify that while copy is greater than 0, I have to specify, I have to first extract the last digit. Then how the last digit is going to be extracted? If I divide the number by 10, the remainder will always be a last digit. So REM equal to copy modulus 10 will be giving me the last digit. Then I'm applying the formula REV equal to REV multiplied by 10 plus REM. REM is exactly storing the last digit. And then I'm removing the last digit. For removing the last digit, if I'm writing copy equal to copy divided by 10 in the quotient format, so I'm going to get only the quotient as the number which has actually removed the last digit. So this will actually what it will do is will change the value of the copy variable by removing the last digit. So these three steps will be executed again and again until the value of copy becomes 0. So as soon as the value of copy becomes 0, we will be moving out of the loop, and it will be printing the reverse of n is REV. So as if we execute this code, you can see that enter the number to be reversed will be printed on the screen, and you will be asked to input a number. And let us suppose the user entered 342. So the output would be reverse of 342 is 243. Make sure that n is left out here. If I'm not making the copy here, I'm using n here only. Then in that case, after the completion of the loop, the value of n will become 0. And so I will not be able to use this value of n here. So in the same manner, I use the copy variable. Then coming to the next example, which is finding the factorial of a number. I hope you know all that what a factorial of a number is. The factorial of a number is the product of all the numbers from 1 to that particular number, all integer, right? And for a 0 factorial, we have the answer is 1. And for 1 factorial, we have the answer is 1. For 2 factorial, we have answer is 2. For 3 factorial, we have the answer is 6, and so on. So like for example, for 5 factorial, you are going to multiply from 1 to 5 all numbers. So you are going to get the answer as 120. For 6 factorial, you are going to get the answer as 720. Right. So what is the algorithm to find out? We are going to have the number in n, for example. Then we are taking a variable f and we are initializing it as 1. We are initializing here as 1 because we have to do the product every time. And whenever in a loop we are doing the product every time, we have to initialize the value of 1 as 1 because the multiplicative identity is 1. In the same manner, in the previous case, we were adding something every time in the loop. So the additive identity was used and it was taken as 0, REV value. Here I'm going to use the value of f variable as 1. After the program gets completed, the value of factorial will be stored in the variable f. So I'm applying the formula f equal to f into n, and I'm decrementing the value of n by 1 every time. And these two statements are going to be executed again and again until the number becomes 0. And then I can find out the factorial of the number. So you can see when we execute this code, initially the value of f is 1, and let us say we are going to find the factorial of 5. So n is 5. So applying the formula f equal to f into n, so I will be getting f equal to 1 into 5. So it will be making the value of f as 5 and the new value of n will be decreased by 1. So it will be becoming 4. Now I will be getting the value of f as 5 into 4, which is 20, and the value of n is decreased to 1 by 1. So we will be getting the value of n equal to 3. Similarly, we will be getting in the next iteration we will be getting the value of f as 60, and the value of n will become 2, and then we will be getting the value of f as 120 and the value of n will become 1. Then again I will be having the value of f as 120 and the value of n will become 0. Because the value of n has become 0, so our condition is set is false here, and we will be ending here, and you can see the value of the variable f is storing the factorial of 5 now. So if I want to write a program in the same manner, how I'm going to do, I'm going to first ask the user to input a number, and then the copy of the number is getting created, and the variable f is initialized to 1. Now, while copy is greater than 0, because I have to run this loop again and again until the value of copy becomes 0. And what the formula is f equal to f into copy, and then copy equal to copy minus 1 I have to do. And it will be at one time the value of copy will become 0 and we will be moving out of the loop. And at that instance of time, the value of f will be actually the factorial of the number n. So factorial of n is f will be giving me the output. So you can see that if a user has entered 7, then the output will be factorial of 7 is 5040. Right, coming to the eighth example. Program to input a number and print its sum of digits. So I hope you can understand this thing that the formula is changed only and it is same as the reverse of the digit. So you can see that here I'm taking the value of s as 0, which is the sum of the number, and the formula that I'm applying is s equal to s plus last digit. So every time the digit is added, and this is done for every digit, and we are getting the answer accordingly, and we will be getting the sum of digits. So if the user is entering 1749, the answer would be 20. Coming to example number 9, program to input a number and find whether it is prime or not. So the most easy or the easiest way to find whether a number is prime or not is we need to just judge that if the number is divisible by 1 and that number itself only, nothing more than that. And so if the number is getting divisible by 1 and that number only, then we will be getting the answer as it is a prime number. Otherwise, we will be saying that a number is not a prime number. So how we are going to do that? We are going to do like this. A number is termed as prime if it is divisible by 1 and itself only. So if we divide the number under consideration by all the numbers up to the same number, and the number of the times it is found completely divisible is exactly 2. It is actually prime number, right? So however, it is completely divisible more than twice, it is not a prime. So how I'm going to do that? I'm going to ask the user to input a number first, and as soon as the number is input, I'm taking the divisor value as 1. So I will be increasing the divisor one by one, one by one, one by one, until the value of divisor becomes the number itself. So every time I'm going to divide the number by the divisor, and if it is divisible, I will be increasing the count value. So initially I'm taking the count variable which is 0, so that I'm not counted it anymore, and the condition would be while divisor is less than or equal to n, and within that I'm checking the condition. If the number when I'm dividing it by divisor is 0, the divisor is the remainder is 0, I will be increasing the count by 1. And every time I'm increasing the value of divisor, it is outside the if part, right? So after coming out of the while loop, I will be checking if the count is exactly 2, then the number is prime. Otherwise, the number is not prime. So if I'm executing this code for 59, it will be saying that the number is prime. If I'm executing the code for 81, it will be saying that the number is not prime. So this is all related to this particular lecture, and I will be giving you more lecture about the same. Stay connected for that. We will be having more statements. We will be having more iterations, right? Followed by the for loop as well. Thank you. Thanks for listening.